Joshua's have blossoms on them now.
Yeah, they have blossoms.
Yeah. I like that. But our coreopsis hasn't bloomed out on the whole. Usually there's just a sea of yellow, but maybe we didn't have enough rain or snow, and maybe they like snow. Anyway, welcome everyone to Plain Crazy Saturday. I'm delighted that we have a full house, but with a subject like Stratolaunch, of course, we'll have a full house. I want to introduce our speaker, Mason Hutchinson, graduated from the New Mexico Institute of Mining and Technology. Now, he didn't go into mining. He went there to get his mechanical engineering degree. He's worked in the aerospace industry for 16 years. He started his engineering career at Ball Aerospace, working on the airborne laser program, focusing on material interaction of laser engagement. It was a lifelong interest. It was his lifelong interest in experimental aviation design that drew him to scale composites. Well, of course, it's a magnet. It is there that he gained experience in design, build, and testing the Spaceship 2 feather deployment system. Soon after, he completed the White Knight 2 landing gear design and release system, and then saw them through flight test. From there, Mason led the flight controls design team on the Stratolaunch aircraft, this big one. Currently, he works for Stratolaunch as a lead engineer for the release system for the Talon hypersonic unmanned system. That is going to be really awesome.
It is going to be.
Yes. Mason said, and this is a quote, "I came on board to design the mechanical flight control system. I've been here ever since the first roll of carbon fiber fabric showed up to build the airplane, all the way through to today." And he's been there for every flight. All 4 of them. Originally from New Mexico, so he knows the desert. Mason is a lifelong full-scale and radio control model aviation enthusiast, and he is the founder and active member of the Tehachapi Crosswinds Flying Club. It's a local radio control model airplane flying club. He was an active member of the team that organized the indoor fly-in at our event center here at Mojave Air and Spaceport. And I'd like to sure do another one at some point.
Yes, wasn't that fun?
Yeah, because it is a great time for kids of all ages, I might add, to actually build an airplane and then fly it. And many times, these kids and their parents have never built a model airplane. And they're just amazed that when they get it all together with the tissue paper and the balsa wood and how well it flies and glides. So then, of course, we have a race and a contest to see who can glide the farthest. And we have prizes, and usually pizza and stuff to drink. It's just a fun time. And that building is so neat. It's the original swimming pool building that the Marines used. They had a Dilbert Dunker, and the pilots would all suit up in their parachutes and flight gear. Then they'd go up this really high thing, and they'd dump them upside down into an Olympic-sized swimming pool, very deep. And then they'd have to get to the top. Well, they're training them, because if they have to ditch in the ocean, they better know how to get back to the top. So, and all of the pilots that trained here at Mojave did go out and fly in the Pacific in World War II. We had squadrons of Corsairs here and GBMs and what have you. And in that building, they got pictures from me. I don't know how they did it. They were 8x10 photos of Bob Hope and Francis Langford. They were here in 1944. And they expanded these photos to 4 feet by 8 feet. And they were 8 by 10 inches. I don't know how they did it. But this giant, Bob Hope and Francis Langford, a giant showing all Corsairs out on the flight line. Just so cool. And then there's one, of course, of Pappy Boynton, because he trained here. And he's in the officers club. Of course, he's got a drink and a cigarette. Thank God not everybody smokes now. But anyway, please welcome Mason Hutchinson.
Good morning. Good morning. Thank you for coming. I'm very surprised that we got such an interested audience and a good big audience this morning. I'm Mason Hutchinson. I've been around the area. I live in Tehachapi with my family. I got 2 kids, one in senior in high school about to graduate, and my 12-year-old son, and my lovely wife in the back there. Thanks for coming. And anyway, I'm really excited to show you this new presentation. I've updated it just this week, gotten all new pictures, stuff you cannot get online, so you're in for a treat. I'm going to talk about 45 minutes, and I'll take questions. Since we're a small group in here, I'll take questions kind of as you see them coming along. So don't let me get away with anything. I have a lot of exposure to this project, but I'd like to say before I get started, I am just one tiny team member among a gigantic team, of course, because you'll see what this effort takes. So let's get started. How do I get slides? Let's see if I can just click. Okay.
Ta-da.
Yeah, there we go. This is me standing in front of Flight 2, about to depart. In fact, I like it because the camera caught the beacon running, which means the systems are up on the airplane. I started the project at Stratolaunch. I had actually quit Scaled Composites and moved to Minden, Nevada to, find another dream, right? And something kept drawing me back to Mojave. And there was a Plane Crazy event, and some of my friends called and said, hey, come down and join us for Plane Crazy. So I drove all the way 9 hours from Minden, Nevada down to Mojave, where they said, guess what, we need help building the mechanical flight controls for this airplane. And they said, are you interested in helping? And I said, I've never designed flight controls for an airplane ever. I'm in. This is my thing. Yeah, so I come from, my heart was in landing gear. So I started working towards landing gear. I did the White Knight 2 landing gear. If you'll remember that, it had 4 sets of wheels. Very hard problem to solve actually with airplanes. So I ended up leading a team of about 9 engineers, sometimes 10, to design the cabling system from the cockpit up here on the nose all the way through this airplane. There's almost a 1/4 mile of steel cable, and that became a problem, and I'll talk about that in a little bit. And that's kind of how I got started with it, and I've been with this airplane ever since. All 4 flights I've been there, and every test taxi, every test event in the hangar. There is so much testing that happens with this aircraft aside from the flight test that you'd be amazed. The flight test is just a tiny bit of what we actually do. So this is me. I'm a model airplaner by heart. I actually built this airplane and took this picture as a resume piece for Scaled Composites. They get resumes all the time, and they're just words on paper. I needed to send something that would make them go, hey, there's somebody we remember. So I sent them that picture. It's actually a picture of me in front of my Albuquerque home. I wanted so bad to move to California and come out here, and Matt Steinmetz hired me, and he's and actually, when I showed up, Bert didn't look at my resume at all, didn't ask me about grade point average at all. He only asked me, what have I built? So I was smart enough to take a portfolio of photos of stuff that I had made, and my resume slid over here on the table, never got looked at, and my portfolio was the only thing that ever got considered in that job. Anyway, I'm a full-scale pilot sometimes when I can rent something. I don't own any airplane right now, but that's a lot of fun. My family and I like to go around places. This is my son when he's a little bit younger. And of course, this is Model Aviation Magazine. In November 2020, they did a story about the model airplaners involved with this big project. And ultimately, this is just a big model airplane. And that's kind of the perspective that it takes sometimes to have the patience to get through some of these crazy designs. So enough about me. You came here to talk about Stratolaunch, or to hear about Stratolaunch. So what is this and why? Why did we build this insanely large airplane in one dimension, and what's it going to be used for? The story's changed over time because it's been now almost 10 years since we've laid the first part. But let's get into it. So, first and foremost, what is it? It's a big giant airplane that was meant to haul a payload. It flies far, it flies slow, it carries large stuff, and it carries heavy stuff. And it'll drop that stuff. And that's really it. The nice thing about it, why two fuselages, is because the payload needs to be in the middle. And I'll show you some pictures in a minute about why that is important. There's approximately 90 feet between these fuselages, and to the best we can measure. And that offers a ton of utility. So the first part we placed in the month of September 2013. We rolled it out 4 years later, almost 4 years later, and we flew it 2 years after rollout. So it takes a long time to get an airplane ready to fly. And when we flew this airplane, it was partially an airplane. It really wasn't finished, and it still is not finished. So
And it was during a Plane Crazy. It was the Mojave experience.
that's right. As a matter of fact, it was flown on the day of Plane Crazy on a Saturday morning. That's right. How exciting for those that were flying to Plane Crazy to get to see that. Yeah. So let's just talk about that first flight day. It was a beautiful day. I had the best job in the house aside from test pilot. I had the second best job, I guess you could say. And that is, I was in charge of the drone team. And I don't know if you know this, but Mojave Airport is extremely friendly with camera drones. You hear about flying drones around airports, illegal, bad. This airport embraces it and allowed us to fly a really nice camera drone while the airplane was flying. Of course, we have to control where that is. So I was a bit of an air boss that day for where that drone flies. I got to stand on the side of the runway, closer than anybody, and film this thing going by on the first flight. It was extremely nerve-wracking for me because I had a lot of skin in the game at this point. Here's the pilots, pilot Evan Thomas, co-pilot Duff. What was his last name? I can't remember his last name. It's Chris Gorante, and then Jake Riley as the flight engineer. There's only a crew of 3 in this giant airplane. And I'll show you a little bit more about that as we get into it. And this is the first flight patch. So those of you who collect flight patches, that's what it looks like. If you ever see one. Not too many of those were given out. They were only given out to those that were involved on the first flight day, which was kind of makes them a little bit collectible. So we can't start talking about Stratolaunch without first discussing the dimension. It's big, right? Everyone says, wow, it's the world's largest airplane. It is. 385-foot wingspan makes it 60 feet larger than the H-4 Hercules. Everyone familiar with what the Hercules is? Mm-hmm. Yeah.
Spruce goose.
Anyone heard of the spruce goose? Yep. That's right.
No.
That's right. So
it was in Long Beach until about 1991.
Yeah.
It's now up in Oregon.
Yeah.
Yep. It's up in McMinnville, Oregon. Yep. And they are so friendly to us. When we had our first flight, they sent out a tweet and mentioned that we get a tip of the fedora from the Howard Hughes Museum, which I thought was really special because he always wore a fedora, right?
Yes.
They also had to change their signage from the world's largest airplane museum to just the H-4 Hercules Museum, which I love. I love that this changed things. So this airplane was on paper designed to carry 550,000 pounds of payload. Now, you don't just design something and go out and load it with that full load and go fly it. It's just not how it works. We have not flown that heavy yet. We've flown about 750,000 pounds to date. The mission radius is 1,000 nautical miles, so the idea is kind of blended with our location right here. The idea is that we take off from Mojave and we go out to the ocean and fly far enough out over the water that whatever we're dropping is no longer dangerous to the public. So, see that better? And then, so it is 50 feet tall, and that isn't the tallest airplane by far. but 50 feet is something to contend with if you're a person that has a challenge of heights and being afraid of heights. And I was the flight controls engineer lead, so I found myself working on the upper rudder a lot. And it turns out rudders are complicated, and the control surface that happened to need the most attention was the highest one off the ground. So I got very used to working up on a scissor lift, and I overcame that fear of heights. That's also dangerous. So balance field length is about 10,000 feet, so it makes it perfect to fly in Mojave. We have a 12,500 foot runway right out here, 1, 2, and 3, 0. And this runway is special because it has a very slight hill, just about a 0.3% grade. Kind of nice if brakes are in question, right? Mission time is designed to be 2 to 8 hours. 2 hours is no big deal. The flight crew really doesn't want to do an 8-hour mission. This airplane didn't have a lavatory designed in. And also, I'll point out for those model airplaners in the room, straight wing, straight flat wing. The last 65 feet has 3 degrees of dihedral, or what technically is called polyhedral, because it has a break out there. So it kind of looks like the model gliders of back in the day. I have a story for why this wing was built in such a silly way. So it's amazing, actually, how that worked out. So because we're talking about the size of the airplane, it comes up frequently to me is, what is the metric? What makes it largest? What is the largest airplane? What does that mean, right? We all have recently heard about the AN-225 in Ukraine being destroyed on the ground. And that was formerly known by the media as the world's largest airplane. Well, I'm frustrated.
Yeah.
By what is the metric that they're calling it the world's largest airplane? So by wingspan, Stratolaunch Rock is the largest, and it's largest by quite a bit, actually. You can see here these overlays. This outline, this double fuselage is Stratolaunch, and it's actually in metric, in meters, and I should probably make this in both metric and in imperial, but it's biggest by a long shot on the wingspan. But by max gross takeoff weight, it's number 2 to the AN-225. It could lift more, and it did lift more, so that's key. Also, interestingly enough, the internet never called this the world's largest airplane until it flew. And I didn't expect that. I figured at some point when we were out taxiing around Mojave and the public was getting pictures of it. Of course, the employees were never allowed to send out pictures during build, so it was kind of a surprise when it came out how big it was. Still not considered the world's largest airplane until flight. So it's kind of a neat natural rule that tended to occur in the media. It's the ranked number 2 by the number of tires. So it's actually a tie with the C5 Galaxy, same number of tires. By length, it's number 3. It's not even close to the longest airplane, and it's not even close to the tallest. It's 5th tallest. So I've been playing with this a little bit more, and I thought of another one this morning. I've got a to-do list of ways to rank this airplane since I'm interested in this. Like, is it the most volume of an airplane? Is it the most area, the planform area, down? Is it the biggest? Is it the most wetted area? Does anyone here know what wetted area means? No. Yeah? Wetted area is like the total area on the outside of the airplane, like all the paint. If you were to add up every square inch of paint, that's what wetted area is. Rank by number of control surfaces. We have so many control surfaces on this airplane. Rank by by pounds of carbon fiber. I believe, and this is only a belief, that this is the world's largest single structure completely made of carbon fiber. And I think that it also has the largest single piece ever made. And I ask every audience that I have, I've given this talk almost 15 times now, and I've asked the audience, can you think of a bigger carbon fiber part than 260 feet long? One single part. And no one's ever challenged this. So
the wing spar, right?
Yep, that's right. And the spars aren't actually full span in this airplane. They're partial span spars, kind of like a glider would be. And So yeah, that is definitely something that I'm interested in. I hope someday someone says, actually, there was a sailboat mast bigger than, or something. But,
Not even close.
yeah. So the other metric I thought of this morning was power to weight ratio. I'd like to rank it by power to weight because it is an extreme machine in that sense. 6 engines worth 50,000 pounds of thrust is a lot of power. What other dimensions might rank this airplane? Anybody think of anything else? I thought of another one. It's vinyl wrapped. It's not painted. So it's probably like square yards of vinyl usage or something, but something silly. Anyway, this is something that I'd like to explore a little bit more over time as we go. What's going on now? Number one word, hypersonics. And you're going to see it here in Mojave. So there is a race for this country to enter into, which is the hypersonic race. And the media places us as behind in hypersonics, and in some metrics we absolutely are. But Stratolaunch now has their mission is to build this unmanned Talon A vehicle, and I'll show you some details of it. I'll actually show you some photos that you can only see here, so this will be kind of neat to get to see. But this is going to be launched from Stratolaunch over the ocean and is going to offer a really interesting reason for it, actually, that I'll get into in just a minute. So this kind of starts a new chapter. So a little cartoon graphic. This is the Stratolaunch releasing the Talon, and this has no one in it. It's unmanned. It's autonomous. It flies on its own. It's rocket powered, and it's going to go Mach. So it's right? We go hypersonic once we hit Mach 5. We're subsonic before we hit the speed of sound. Then we transition to supersonic. Then we're at Mach 5, we go to hypersonic. And the reason why that's different is air really doesn't know how to get out of the way at hypersonic speeds, and it turns into a plasma. And that plasma is extremely problematic for stability, temperature, radio control. Things happen when you have plasma surrounding your vehicle. So what we're going to do is we're offering rides on this for your instrumentation, right? So we've got customers that are interested in putting this nose is hollow, so they're going to put their instruments in there and go Mach 5. Right now, the best wind tunnels can hold Mach 5 for a split second, but they can't hold Mach 5 for a long time. We can't stay on condition. So what this is going to be minutes of on condition time. No one in the world's done that. These hypersonics that you're hearing about from Russia and China and they're glide vehicles. So they go up in space and they come back in and they're going fast. We never leave the atmosphere. We're just going to go up and go fast for a long time. And it's gaining a lot of interest. We're actually quite far down the road on these airplanes. We've got 3 of them sitting in the hangar. So what's that mission look like? Well, for the big airplane, for the launch system, it is, make sure you can see too, it is basically, imagine this is Mojave. I know it looks a little, we wish it was this close to the coast. Just bear with me. But if this were, we're taking off from Mojave. We've got the rocket on board. Excuse the wrong rocket in the graphic here. We had different plans the day this was made. We fly out 1,000 miles over the ocean. We can cruise out there, loiter for about an hour to get ready. And then when we're ready, we'll do the launch, which is, they show this as a pull-up, a release, and a recovery. It turns out for this little hypersonic aircraft, we're not actually going to do the pull-up maneuver. We're just going to let it fall and fly away, which is better. But we have the fuel to loiter for another 45 minutes in case we need to recycle and try the release again. Then we have a fuel to get back and land. That hypersonic will have launched, gone on its hypersonic mission, return to the field, and be towed back to the hangar before this airplane makes its descent back to Mojave. So it is a rapid mission, and this is the plan for the launch system, right? The airplane, Stratolaunch, releasing the Talon. Well, let's look at what just the Talon does. So now put yourself in the seat of the Talon on the hypersonic vehicle. This is kind of the ground operations here. What we do first, we get it ready to mate, ready to roll out. We fuel it once it's on the airplane. We don't fuel the rocket and then put it on. We actually put it on and fuel it. Then roll out for takeoff. So fast forward, we're cruising. This is supposed to be odium, but it kind of looks like ground to me. And the hypersonic is released from the Stratolaunch. It ignites, gets stable, and then goes out on its mission. And there's some altitude changes, but it stays inside the atmosphere always. And it goes through a burn and then comes and glides back. So it'll burn out and then glide back. And this all happens inside of a range, a test range. And there's numerous test ranges we're talking to. The first release we do of this will likely be in the Edwards range, 2505, if anyone knows their aeronautical charts. So the idea is it lands on a runway, kind of like Spaceship Two, if anyone ever saw that land, very nose high, but it's an autonomous landing, so no one's actually flying it. And then it'll stop on the runway, and we have to go out and tow it back. So it doesn't have any way of getting back in. So that's what the mission for the Talon looks like. Here's what a Talon actually looks like. So I showed you this picture in the beginning. Here's the airframe that we're allowed to show. It's now a little more populated with systems, but that is a high temperature carbon. It kind of has a brown tone to it. It's a very high temperature carbon fiber. And these little pucks around it are used to use a laser to track and make sure we got the build just right and that the sizes are kept right. And it's on this pedestal so that workers can go underneath and access the access panels underneath. So we drop in tanks in the top, there's a rocket engine in the back, bell, and then technicians go up underneath to set the landing gear and lock them up and to get the systems, and these are the payload bays for our systems, and where we're going to offer the ability to sell rides, if you will, for the instrumentation. So that's what Talon looks like. That is the mission of Stratolaunch as a company. And I'm an airplane guy, and you're here at Plane Crazy, so I wanted to kind of show you the history of where the airplane came from. And so launcher aircraft have been around. The concept has been around for a while. We would never claim that this is a unique idea. Twin fuselage, central payload. Even the Hughes Kaiser company, when Kaiser was involved, they came up with a version of the Hercules that was a twin hull, multiple engine. Look at the number of engines on this thing, centrally mounted. And the idea is their idea was it would be the payload inside the fuselages. And they were just getting more payload capacity for one wing build, is what they were looking for. But can you imagine touching this down on the water on your first landing, maybe a little wing low? Like, I can't imagine, like, we're not perfect, right? So, I mean, most of us are gonna walk away, but that one, wow. It looks like there's windows in the left fuselage of this. There's hard to find information about that concept. Obviously, it never got built. Fast forward, in the 80s, or in the early 70s, we had our shuttle program coming up, and there became very clear evidence that they needed to carry the orbiter from Kennedy to Edwards and vice versa, and we needed to move that orbiter around. So then the ideas started flowing. Well, how do we do it? Before anyone came up with the top launch idea, they were considering cutting two C5s and putting a wing between them. And I want to point something out. Look at the engine here, inside, in between those fuselages. Like that's so crazy. And the upside down W-shaped wing, that anhedral, I just can't imagine as an engineer what it would take to engineer the joint, that wing structure in the middle, what it would take to modify this airplane to do that. Just very expensive. It just looks nearly undoable to me. At the same time, there was a company, maybe even a personality, Conroy Burtis, came up with the idea of reusing B-52s, because in the 70s we had a surplus of B-52s. So let's cut the fuselage off. Let's build a straight Hershey bar wing. We'll use bigger engines than the B-52 has twins on a pylon, two engines on each pylon. Well, in this case, we'll use something a little bit bigger, like a CFM or something like that. And we'll drop the orbiter that way. And he said, I can build each one of these airplanes for $12 million. And of course, everyone, even in the 70s, said, no, that's not going to work. So this concept never left the ground. But look which one did. This is an American Airlines airliner. They still have the cheat lines on it. And it is the first time it's top dropped from a 747. And this was a highly contentious idea. It was so contentious that the guy who came up with it built model airplanes and went out and flew those models right here at Edwards and proved with models that you could release the orbiter and not have it recontact. We use the word in the industry, we use the word recontact to be nice. Yeah. I don't know if you've ever had a bumper recontact in traffic, but they often involve insurance and things like that. So yeah. So the driver of this airplane was Fitz Bolton, actually. Yeah, and so local history.
Tom McMurphy was
in the orbiter.
Yeah.
So very famous picture. I love that it's local. I'm excited to finally give this talk here because I've given this talk in New York City and standing in front of that actual, or very near that actual orbiter, and a lot of people don't know that history. So I'm very pleased that we do. So.
Gordon Fullerton.
Yeah. We have a local legend around here. Anyone recognize this beautiful L-1011? If there's ever an example of an L-1011 to look at, it's this one. It now says Northrop Grumman on it, I think.
Yeah.
But
last flying one in the world.
it's so gorgeous. It belongs in a museum itself. It is just one of, and this, the crew that ran the one here very much partnered and let us do training. Our flight engineers flew on this for training. Yeah, lots of collaboration there. Our engineering teams got to go scour the release system. But look at this. There's a rocket underneath this airplane. It's on the center line. It's on butt line 0. But notice how close to the ground it is. You have a fueled rocket a couple feet from the ground.
Yeah.
And if there's anything that goes wrong, the first thing you do is want to come back, RTB, return to base. You want to come back and land. Well, that's kind of risky. And what we wanted was this kind of lifting capability, but we needed much more space. We need a bigger rocket. So that's kind of the inspiration there. So the model works. You just need a bigger airplane. So here's one of my favorites. This is the evolution of Bert Rutan's thought process on how to approach the carrier aircraft. And it actually started way back in the 90s. Found this drawing. This is April 6, 1990, model 205. So Bert named his models. He never put a name on them until they were getting close to being built. He always numbered them. And he never really revealed to the engineers what his numbering system meant, but it means something, and people know, but I don't. And he promised he'd tell me someday, but we haven't got there yet, so we'll see. Anyway, he sketches a twin fuselage design, and it's huge, and it's using airliner engines, because he likes the reuse idea. Why redesign a pylon? That's a very difficult thing. An engine pylon for an airliner is very compact, very well solved. So let's use them. Here's another evolution of that. This is model 333, and you can kind of see the makings of Spaceship 2 here. It's got a canard.
Yeah.
Because I think the canard just gets drawn, by reflex. But the crew is in the right-hand fuselage, and then here's 4 or 6 turbofans. He's got 2 turbofans hanging under the wing, and maybe an optional 5 and 6 above the wing, even, like if you need more there. But the musings of this are starting to come. You can kind of see the theme starting to happen here. Straight wing, easy to build, 2 fuselages. Scaled has plenty of experience with that. Just look at Voyager and Global Flyer. So moving on, here is August of 2000. And this is when Bert wasn't big on CAD, so you can tell he started paying people to do this at this point because he's getting real CAD cartoons, and then he'll go and sketch on top of them, which is a very, very typical way to do it, and it actually works really well. But look what we've got. These are, if you imagine that these engines are airliner sized, like Pratt & Whitney 4056s or something like that, let's imagine them on top of the wing here. How big is this? It's huge. So the concept really starts to work out. He's got 2 conventional T-tails and a good low wetted area. but the landing gear is just excessively tall, and it's almost the entire project becomes undoable because of the cost of that landing gear, making it that tall. The Constellation, who's familiar with the Lockheed Constellation, the 4-engine airplane? Beautiful 3 vertical stabilizers, one of the most elegant airliners there ever was. The landing gear on the nose was a challenge for that one. We're talking taller than that, and that's when you start to get into where the systems have to evolve to your airplane design, it might be time to rethink your airplane design, because systems are really, really hard. And then of course here, the concept gets even more elaborate, even more resolved even with more design, and it's getting now to the point where they're applying actual math to the sizing of the aircraft. So the wing is being sized, it's now, the airfoil is probably getting close to being chosen. This is actually moving along. So let's move to, okay, so now, one more musing from Bert. Now this is where it gets fun. He starts to think about pilot safety in this and pilot experience. And Bert is all about the viewing and the experience. If you look at White Knight 2 and Spaceship 2, it's 3 identical fuselages, 3 identical noses. And that was originally thought of to make it easier to make 3 noses, 1 tool, 1 mold. If any of you have done fiberglass or carbon fiber, the tooling is where the time is. And so for that aircraft system, or that launch system, he used the same mold across all 3. Incidentally, there was a left fuselage on White Knight 2 available and unused. And what's Bert's idea? Put people in there to watch. So his idea was to have the family sitting in that left fuselage and wave goodbye to the lucky one in the spaceship as they drop away and go on their space flight, kind of like Richard Branson did last summer. That never happened because in an experimental aircraft like this, the FAA doesn't like just passengers. Everyone has to have a job, and because it's experimental. So the fuselage still flies empty and with no windows. So it has decals for windows. But here's what's fun about this one to me, and this is my favorite part of it. The pilots sit in the top of the fin, up above the rudders in the very back of the airplane. Imagine that as a pilot looking down on your airplane from the top of the rudder. Can you land it that way? Like that? You can't see the mains. It's like you can't see the mains touch that. Like that concept. So how does the pilot get out in an emergency, like an emergency egress? My favorite part of working with Bert. He had a playground slide inside the rudder that went all the way down, and the pilots would slide down that slide and then come out the bottom, just like that, and there they were. They could do that. Of course, we never built it this way, but he was so smart that he even had the mold kept from the V-Jet, which is still sitting in Oshkosh. If any of you have been to Oshkosh Museum, there's the little V-Jet with the V-tail. That mold Bert saved to use as the cockpit at the top of the rudder of this early design. Okay, so he's got interest coming now. Now Paul Allen's circling. We've got people with money that are ready to get on board. So he gets it resolved into an actual flyable airplane. Except, look at this wing. Hey engineers, I designed something, go out and build this. And we look at that and go, just shake our head. That's going to be crazy. Anything curved is just really, really hard to build. So this is actually the evolution. Here's the cockpit from the V-Jet. Here's the window and the door. Solid rocket motors from Spaceship 2. Because we had spent the time developing Spaceship 2. We understood those motors, so here's some motors there. This is the agreed configuration with Stratolaunch when we went on contract. That's what we were going to build. But this is all before we start laying actual pen to paper and really start to design. So this is the last slide on this history. Here we are developing that concept, and it gets difficult, and we start to realize, okay, it's not actually appropriate to put the pilots up here at the top. Did some experiments, did some simulator flying actually, and the pilots tried it. Fun to try, very difficult to fly. I even tried it myself. So it moved to this concept. Look how close to a 747 this looks. And the idea is, hey, let's get a couple of 747s and we'll reuse as much as we can. And we had actually considered using the forward nose section of one. And then we started to realize how hard that actually would be. Take an aluminum airplane and strap it on the front of a carbon fiber tail, or it just wasn't going to work. So we moved to this concept, which is basically an all-new carbon fiber airframe, but we reused the windows from the 747, which I think is one of the most clever parts of this design, is reusing the transparencies from the 747, because one of the hardest things to get made, every airplane window is a different shape. So getting them made is extremely difficult. But if you can ask a company to give you a new set from a mold that's already out there, you can get them all day long. The launch pylon is kind of a cartoon at this point, so it's not very real. But the airplane that's the mold line that we built. So this is called the Rev H OML internally, and OML stands for outer mold line. So we actually use that as a CAD model, and all the design engineers have that on their computer, and they can find out exactly where the airplane is in CAD. So that's where we're at now. Wow. It's about 275,000 pounds of structure, approximately. So one of the things that made this really hard, and this is kind of an interesting part of why the airplane is the world's largest airplane, and it's not that big, actually. And the reason is the wing is built so thin, and it's built thin for range, because you get a lot of good, efficient, low drag, but it's straight for cost. To build a wing that's curved in a tool, in a mold, and I'll show you in a bit how that mold actually looks, would have been very difficult. So, how did we compute the size of the wing and those spars? There are 5 spars in that wing.
Wow.
And it's no thicker than 5 feet at its thickest in that cord. And it's the same airfoil from here to here, where the black edge is. And then once it hits the wingtips, that actually changes the airfoil slightly. A little bit different airfoil at that point. So the root bending moment, so the maximum load that wing can take, like why doesn't it break in between is the question we get often. And the reason is because the root bending moment, moment is like foot-pounds of torque, and that same concept, well, a foot-pound of torque is 1 pound, 1 foot away, creating torque. This would be the same as an elephant on a wrench 1 mile long. So then we have a moment in that wing that we have to contend with. So we designed the wing to handle 1.1 elephant miles of just a little bit more strong to make sure we cover that load case. And the last thing that we are concerned with is the strength of that wing in this whole endeavor. And it's funny because the public is, when we put it up on YouTube, the comments roll, and about half of the comments are about how the wing looks like it's going to break. And from the engineering point of view, it's funny to us because that is probably the most comfortable aspect of this. So Kathy mentions there's an A380, 2 A380s sitting in the boneyard. This is the cross section of the wing root of an A380, and I love this picture because there's a person working on it, and you can see how big that cross section is of that wing root. Here's the H-4 Hercules coming down the street in Burbank in the 40s, I think, and you can tell just kind of by the scale of the people walking, big cross section, and I've had the opportunity to walk down the wing of the H-4 Hercules sitting in the museum in McMittenville, and I can stand up in it, and I'm over 6 feet tall. This airplane's only 5 feet, and you cannot access other parts of the wing. It's blocked. The ribs, it's so structural that there's no getting in there and accessing it as a human. You can only go in access panels. At one point you could crawl through it, and we made the boss, Kevin Mickey, the president of the company, we made him crawl through the airplane, and that day he wore an all-white button shirt, and he came out with a pretty much gray shirt, so it was great. So anyway, that's kind of one of the harder things that we conquered right from the beginning. So, yes sir.
Did you do some calculations as to what it would take to either make that out of aluminum or even titanium?
Absolutely, yes.
And it was no comparison, right?
No comparison. And the reason is aluminum in that size. So we couldn't get, the mills no longer cast aluminum quite that big. and that the investment into those castings would have just run us out for the bigger elements. Actually, though, we did end up using the pylon that we bolted on, that you'll see in the next flight, Flight 5, is all aluminum. And it turns out that that structure was more beneficial to build out of aluminum. The market has changed, and we needed the stiffness that aluminum offers over the carbon in that particular case. And I'll show a little bit more of that as we go. So here's a privileged picture. This was made this week. This is the CAD model. So every bit of this airplane is realized in CAD. Boeing did that in the 90s, and it made the news. When they came up with the 777, and they said it's the first airplane entirely realized in CAD. We've been doing that for a while, and this airplane is, of course, entirely realized in CAD. So this was, as it sits today, we have an all-new composite structure. No part of the 747 was reused in the structure, but we reused the engines and their nacelles. We reused all of the flight control actuators, so the hydraulics that move the flight controls, every one of them reused from the 747. We reused the entirety of the landing gear. So the landing gear legs that you see on the mains, they're the body gear of a 747, not the wing gear, and they're unmodified. So the tires on the mains are the same as the tires on the nose. The 747 was a really smart airplane. They flew it overseas, that was its job, and it made it highly utility to be able to swap tires from the nose to the mains. And that's not a typical thing. You see on most airplanes, you have different sized tires. Well, for us, we use the retraction system, and we had to make our own gear doors. So this airplane now has 34 gear doors. If you've ever rigged one gear door, I think you'll appreciate how much work 34 took. We use 6 Pratt & Whitney 4056 engines unmodified, except we disabled the reverse thrust. So you're flying on an airliner and you land and you see the cowling slide back and it throws the thrust forward. All of that is there on our engines, but we just disconnected that capability because we wouldn't want it to accidentally activate in flight. Yeah, that would be a terrible, terrible day. We'd have to shut that engine down. We have plenty of engine power, so we can run with an engine shut down, no problem. Takeoff power is not even half. When we take off, we're not even at half throttle yet. It's very low EPR, engine pressure ratio. All right, so the flight controls, it was my job to lead a team to design the signaling system. And just like the Hercules and the C5 and a lot of other airplanes, and the 747, it is steel cables from the cockpit out, down the fuselage, out to the wingtips, to the ailerons, all the way down to the elevator and rudder, but also back over the wing and down the tail to the elevator and rudders back here. There's 2 rudders per tail, 2 elevators per tail. And what happens when you have a carbon fiber airplane and steel cables running the length of the airplane, and you take that and you go up to altitude and it's minus 65 degrees. Things get cold, metal shrinks, carbon doesn't really. But it turns out carbon on this scale grows. So ice, when you put water in the freezer, it's one of the few materials that expand when it freezes, right? Ice will get bigger, and it's a problem for pipes, right? Burst pipes.
Yeah.
Carbon fiber grows very slightly when it gets cold. Not as much as water, but it very slightly grows. So now we have this problem where as we take off and climb and get cold, our cables get screaming tight, and that causes the control friction to go out of bounds. And now the pilots can't control the airplane. So we did something very clever, which I'm very proud of, and I can't show the exact details of, but we took out some of that steel cable and we put in carbon fiber cable made for sailboat rigging. So we got with a sailboat, we looked at racing sailboats, and they rigged their masts with carbon fiber, these beautifully wound carbon fiber ends with titanium ferrule fittings. How do they do it? So we called a company. Man, we don't want to touch that project. No, once they found out we wanted to put it on an experimental airplane, they won't even answer the phone to us. We found a company in Spain that was interested in playing, and they built us our car. So now, in the tails, we have straight cable runs that are all carbon fiber, and they communicate, so they grow with the airplane, And what it turns out is we've got it tuned in such a way that now our cables don't change tension at all in flight. Take that 747, you had to make a thing for it. The 747 designed a cable tension regulator that lives under the pilot seat, and it keeps the cables in that airplane, because the 747 has the same problem, but in the opposite sense. They have an aluminum fuselage and steel cables, so when they go to altitude, their cables get too slack, and now they lose their control fidelity. So they do that by making a device to fix it. There is nothing in so having the opportunity to reverse engineer a 747, there's nothing in those airplanes that are extra. Everything built in those are exactly what needs to be there. So unlike a car where there might be a few features we're not using, not Boeing. If it doesn't get used, it doesn't fly. So it's the most efficient design. It's very impressive. All right. Oh, I'd be remiss if I didn't mention the flaps. Our flaps are more like speed brakes. They're actually split, so the trailing edge of the wing and the flap, it leaves the trailing edge there, and the flap comes down to a very steep angle. There's 14 flaps.
Like a garage door.
Yeah, and they're actually bang bang. We don't have multiple flap settings. They're either up or down. That's it. But they're 4 segments, so you have outboard flaps and inboard flaps, and that's how you adjust. Lift is not a problem for us, so we need to kill the lift. And there's a couple of maneuvers where we actually climb with flaps down because we've just got too much lift. It's just not right. So we did a bunch of tests recently in the gear retraction test where we were flying flaps up and down with gear up. And so that kind of. So yeah, there was a question.
By using cables, you didn't go fly-by-wire, right?
Correct.
Did that save a lot of money or engineering or?
It saved in engineering time.
Yeah.
And the Boeing is very good about that too. It also uses cable signaling. And in the event that a cable breaks, there's a backup system in a 747. So we emulated that, and we have backup. We have dual cable systems for everything. Mm-hmm. But since we've flown, we've then modified that, and we've added electronic servos. So we're now control by wire, not fly by wire. And the difference there is there's no flight laws involved. It's just direct from the stick to the surface. So now these are actually, the outboard ailerons are the only surface that are electrically signaled now. The cable no longer goes to those. If they fail and they go hard over, we have enough ailerons on the wing to overpower the failed ones. And that's how we manage our failure modes, is how much power each of the surfaces have over each other. So now, we first flew with all mechanical system, and we literally, in the hangar, cut the cable and checked what it did to test that those cable systems work if in the event that a cable fails, which they don't, actually. I don't know, incidentally, airliners such as the 747, when they ship from the Boeing factory with flight control cables, they will be cut up in the boneyard with those same cables in them. They last the life of the airplane, which is very amazing to me. The military, on the other hand, when they take a variant from Boeing, they actually have a maintenance requirement where they have to change their flight control cables for fatigue, and that's a military requirement, never needed in the civilian world. Can't find the connection there, but I think it's interesting that the military will change their cables for fatigue, but the commercial world never does, ever. So anyway, so internal name is Rock, and the reason for that is short, one syllable. We're going to be saying the word millions of times over the next years while we build it. So we always have an internal pet name for our projects that are simple to say, and in this case, it's a Greek mythology character that is a two-headed bird that can pick up the weight of an elephant, and that's what. And so it's actually specific ROC. And it's funny because a lot of people call it The Rock, and you know, and that is a person who acts on Disney movies. So, and someday it is my dream to have The Rock in the hangar with Rock, but he won't answer the phone. So what's in the fuselage, or what's in the cabins? What do the pilots do? Only a crew of 3, remember. So pilot and co-pilot, just the same. What we did is we literally cut the cabin floor out of one of the 747s and put it in a carbon fiber cabin. So the seat rails, the instrument panel, the yokes, the rudder pedals, everything, the spacing, the eye line, where the pilot's eyes are set for the windows, that's all very specifically designed, and we captured as much of that as we could. We've got a few mistakes. Right here on the pilot's left, there's a beam, and his helmet hits it. And we can't trim that away because it's structural now. So we did the best we could on that. Pilot, co-pilot, and flight engineer. Flight engineers, just traditionally like a regular flight engineer, sits in the back, looks at the gauges, controls the hydraulics and the electrical system, and for our airplane, the payload. So now, the science project happens with the flight engineer, while the pilots, they're doing just the job of flying. Behind them, this cabin's big, it's 10 feet long. You cannot access any other part of the airplane from this cabin, it's pressurized. So these little holes back here are really just where the bundles of wires come in to the cabin. So there's stuff monitoring other stuff, airplane stuff. So these are like the aircraft batteries are in the cabin, all the breakers, the power handling systems, what we call LRUs, line replaceable units, they're back there. The one thing that's not in here is a lavatory. So we're asking the pilots to do 8-hour missions, so that's their lavatory. Anyone who's flown long hours can appreciate the flight Johnny. Yeah. All right, so we bought 2 747s, tired 747s from United, sister ships. They actually had a serial number 196 and 198. And the great thing is when we flew those into Mojave and parked them in front of our hangar, the original pilots that flew those airplanes found us and came and introduced themselves to us. So we had some of the original pilots, because they lasted so long, they had multiple pilots. But we got these from Victorville, and Doug Shane, the original president or one of the presidents of Scaled, flew one in, and we brought them in here as old tired airliners and parked them in front of the Scaled Composites hangar. And if anyone's ever been past Hangar 75, the original Scaled, this was the most intimidating possible company meeting that I've ever experienced in my life, because this is the day they showed up with the airplane and said, we're going to take the parts out of this and build that. And here's me standing there going, yeah, right. That landing gear is taller than me. That is extremely intimidating. So there's a group of us engineers standing in front of the Scaled hangar going, this is crazy. I don't know what we're going to do. That landing gear now lives in the nose of Stratolaunch. Yeah, oops, I clicked one too fast. So there's the parts bird after the engines are gone. We took the control surfaces. We took out ECS. We took out computers, brake controls, everything we could think of, except the cockpit. We didn't think of that yet. So as we were working along, we discovered we need the cockpit. Literally a sawzall and an afternoon in the boneyard. Later, and a rented crane, we had our cockpit. We ended up plugging 3 of these out. And once we were done with these birds, we sold them to the boneyard, and their fate, I'll show you. So here's the 2 sister ships, 196 and 198, and we cut the cabin floor out here, ended up leaving that there, and then this is their fate. After they're done, this is literally the sound that makes is
horrible.
The most horrible, crazy thing.
Sounds like they're screaming.
It does, and what was interesting was we took this rudder and the flight and the actuator out. These are all the harvesting jobs that we had done. And that's the fence of the boneyard. This is some of the hangars that are distant. Okay, so how do you take those parts and build a big giant airplane? Who knows what that stands for? That's right. That's right. We got to keep the requirements focused. Here's a picture of the horizontal stabilizer laying in a tool and the 2 elevators. And on this particular day, the team's objective was simple: install the elevator to the stabilizer. We did it like that. Like, it sounds overly simple, but it's on purpose because it focuses everybody, and they say that's what our job is today. Now, there's a million things you do in between that, but it still works out that way. The other thing we did to keep this thing simple was we built the airplane flat. You see this fuselage, it goes from round and it flattens out and it's all flat sides. The only reason we did that is so we could build the parts on tables. Because the bigger, the more curves you have, the more tools you make, and it just gets, it's already so wildly expensive. I remember our boss came in and told us, okay guys, we're building this airplane for M's, not B's. And that stuck with me. That was actually one of those things that I thought, oh, okay, yeah, that's true. We used Garage Tech whenever possible. I love this one because I'm a model airplaner. This makes me so happy. Here's a leg, here's a foot, this guy has a rivet gun jammed into the jaws of a vise, and he's needing to put 2 parts together, but he needs 3 hands. We've all been there.
Yeah.
So he just made a duct tape pedal on the floor and was able to set the part in and hit the switch, and it would actually rivet, and he made a rivet table. They make tools for this, and you can buy those tools, but they'll get here in 2 weeks, and they cost thousands of dollars, and you're waiting to get that job done. We figured out how to do it like you're building a home build, and just get the job done. And along those lines, let's see here. Along those lines is, don't reinvent the wheel, especially if you can buy one. So we have our landing gear sitting out here from the 747, and on this table in the middle is a mock-up of the brake hydraulic system. Oh my goodness, are brakes complicated on airplanes. They're not like a car, well they are, where they have hydraulic that goes to the wheel. But everything in front of that, oh. So there's anti-skid, there's there's de-spin, right? So when the wheels retract, you want them to stop spinning and then retract. There's like missing wheels. So like if one goes missing, a tire blows, it knows to, if you have a leak, it has a leak detection system like this. Oh my goodness, the brakes on airplanes are crazy. And we had to set up this experiment and run it, but that is the system that flies on the airplane now. We had a bunch of, oops, I apologize. We had a ton of people working on big, long, spindly parts. Here's a spar cap, kind of the top of an I-beam, it's upside down, and it's 260 feet long.
Wow.
The problem is if you flip it on this end, that end all the way down there doesn't flip.
That's right.
So, I thought this was genius. Someone cut foam, tooling foam, and look at these slight facets, just very slight facets, and it's a foam wheel that's set every so often, and now we could take that, one person could roll that spar over, and the whole spar would roll in the hangar and flip upside down. And I just thought that was genius. The whole thing is held together with a ratchet strap around it. So just that whole concept of surrounding yourself with people smarter than you, it works. It is so real. That's why I'm standing here today. The parts go where you think they go. Remember getting the plastic models and you look at the sprue and here's all the pieces and you automatically see the airplane. You see the wing panels and all that. Here's the forward fuselage getting put in place. It gets held up. Here's wood beams that we had temporarily built so that they would hold the wire harnesses. At this point in the game, the electricians were outpacing the project, so we were building wood fixtures for them to strap their wires to as the structures folks were catching up. And eventually that pace, that it trades back and forth. Here's adding the tails. So we built the tails on the floor and then lifted them up as an assembly up to the airplane. And there's one of the tails sitting here. Here's some people for some scale. And they actually don't weigh that much. They're in the order of 15,000 pounds at this point. So no surfaces on them yet. Try to keep them as light as possible. I like this picture just because it shows scale. This is looking down, and this was taken from when drones first started coming out. This was taken from an early DJI drone, and it's great because the surfaces are on, and it just shows kind of the immensity. And this is a bridge that we frequented. Like, I would walk that every day. This is up on a fixture, a temporary tool fixture, and we built the wing in place. So the wing was built up in the air, kind of where it goes. Lifting the engines was hard. Boeing makes great tools for doing all that, except the 747 has dihedral. Everyone knows what dihedral is? It's that angle of the wing, that upward angle. Well, we have no dihedral, so their tools no longer work for us. So we had to modify the Boeing tools, and these are literally the hoists for lifting the engines up onto their pylons. So this was the day engine number 6 was being put into place. So here's the exclusive thing you get to see that you're not going to find on the internet, and I mean it, you won't find it on the internet. This is the hangar before the first part was laid. This was the month, July. We actually laid the first part in September of 2013. The hangar was built specifically for this airplane, and the company that made the hangar was from Germany, and they do this fabric door design is very popular in Europe, and now we have what we think is the largest free span hangar, certainly in the county, and it might be, it's hard to tell, it might be in California, but we're not entirely sure. It's a big hangar. Wonderful model airplane flying when the airplane's not in there. Oh my goodness.
As long as you turn the fans off.
Yes. Yeah, there's big giant fans hanging in the ceiling now that are the super diameter fans. So what I did was I clipped out a few frames from a time-lapse camera. We had a camera, several, mounted around the hangar that took pictures on, I think, a frequency of 8 to 10 times a day, maybe more. But we got about a 9-year time lapse out of it, and it's fantastic. So here's October 2013. Look what's sitting in the hangar here. Anybody recognize that? That's a piece of Mojave history. That, hard to see, that's White Knight 1. So it was actually stored here in flying condition until it made its final flight to the Washington to the History of Flight Museum. I'm not sure the name. Paul Allen's Museum. It flew there very shortly after this, and we just happened to keep it in the hangar, and it got caught in a couple of pictures. No longer a flying airplane. They do special things to make them not fly anymore. Okay, here's the next. I'm jumping frames quite a bit, but this makes a major jump from having just the airplane. Oh, let me go back. I want to point out we have spars laid into the tool. So that is this inner spar, a couple of them, lower spar of the airplane, and these white things are going to house all the group of spars. Almost, that is not quite the full span of the wing. We're still 120, 130 feet away from the full span of the wing at this point. These are the wing tips being built down at the bottom, 65 more feet each. And they're being built on the floor. So now these got moved up, and now they're joined. So we're at the full 385 span now, we think. We still don't know exactly by the inch what the span is on this airplane, because it's just how do you measure that to the inch? Even your tape measure will grow and shrink to that kind of distance. So here's what we'll point out here. The wing spars are complete. The main structural is done for the wing. Now the fuselages are being built in place, and they're raising a cabin. So the left-hand cabin is being put up. The left-hand cabin has no one in it, but it's pressurized, and the same as the right. So the right-hand side's where the people are. Left-hand side, no one's in it. Any idea why we would do that? Why we would pressurize an unmanned cabin? We built 3 of these cabins entirely, start to finish, with the windows in it. One of them was used to pressurize and test what the ultimate pressure would be before it bursts, because they're pressurized cabins. And because we had all that test data and all that effort, why change the design on this side? It works. So we just used it. And it was saving engineering time, not materials. And so that's why there's windows in the left-hand cabin too. Because why redo that? Why have to do 2 tests? So, and weight is not much of an issue on this airplane. You can have heavy things, and it's the first time in my career that weight is much less of an issue for flight. So here we are, the cabins are installed, full structure from nose to tail, and now the tails are installed, but no flight surfaces yet, and no engines yet. Landing gear is in the process of going in, but not quite there. So the airplane's hovering above the ground. No landing gear, no engines, no flight control surfaces. Okay, so now let's fast forward. We're getting close to rollout. We got our engines on, so the airplane balances now. Our gears on, and we're down weight on wheels. This was a big day for us. Weight on wheels is a big day for any airplane, and that for us was the first time we rolled out. We didn't even have leading edge parts made yet. There's what rollout looks like. I like this shot because finally, after 8 years, we have an empty hangar, and 6 years actually, we have an empty hangar, and it's. I had one frame and I couldn't get back to it, but there was some of us flying RC airplanes back here in the back part of the hangar. And a black scissor lift, because apparently if you're in the movies and you're a camera person, you got everything you drive has to be black. I don't know what that does, but this was for Discovery Channel came in and did some filming, and there's a show out there on Discovery you can find. I think it's called Extreme Engineering. I haven't seen all of it yet. So then airplanes back in. Here's right before first flight. This is the day before first flight. We've got Chase is a Cessna Citation, and it is a well-matched airplane until you put everybody in a seat. And actually, Stratolaunch outperforms it. Stratolaunch outclimbs it in every case possible. The Citation can't keep up. So we can only fly 2 pilots in the Citation and up to 2 people in the back with cameras, and that's as much as they'll take in it. So that is the day before first flight. And in the left fuselage, we have air stairs up here because it's tradition to fly a token of something on the airplane for first flight. Well, when you have a team as big as we had, that little something turned into a trunk. It looked just like a toolbox that goes in the back of a pickup truck. And it was full of mementos. They told all the engineers that you get 1 business size envelope, and whatever you put in this, whatever fits in this, you can fly. Don't ever tell engineers that whatever you can fit in an envelope flies. We had the most cylindrical envelopes you will ever see in your life. That's the most efficient shape. So anyway, so that's what it looked like. It got built in this position. It got set on its wheels in this position. Today, it's sitting in the hangar in exactly this position. It fits one way in the hangar. It's a specifically built system. And it actually, it fits well. We've got the routine of putting it in and out down. It takes 2 people on 2 tugs pulling on 2 ends of that airplane, coordinated, and they have headphones that talk to each other, like dirt bikes maybe, and like an intercom system. So really cool how that works. So let's talk about how it's flown. We're currently in a flight test program. We just completed Flight 4 a couple weeks ago. Flight 1, first objective, fly and land. That's it. It's safe flight to landing. Only 1 landing. We will never do a touch and go with this airplane, by the way. It is too complicated, and there's too many brakes to worry about. And really the main reason is the track width is so wide on this airplane that you don't want to risk going off the runway. So we do low approaches, and we'll get down to about 100 feet and then take back off. So if you see a touch and go, it's off. It's not normal. So it's an off nominal condition, and it can happen, and it can still be safe. Not that it would be a dangerous situation. It's just we aren't planning on doing those. Flight 2, we installed the nose gear doors. So the gear's down and fixed for Flight 1, and it can't be raised. Same with Flight 2, it can't be raised, but we get a cabin noise. The pilots start complaining of a rumble. You ever roll down the back window in your car on the highway, and it just throbs your ears? That's happening the whole flight. So the pilots are going, okay, something's up, what do we do? So Flight 3, the focus was to track that down, and then retract just 1 main gear. And when that 1 main gear went up, that throbbing changed. And so they went, okay, we've got something there. So Flight 4, they retracted all gears, and I'll show you a video next, and all gear doors, and the noise is still there. So just this last week, one of the interesting ways that they're testing this is one of the guys in the parking lot has a car with a seriously loud subwoofer. We've all heard it. It rattles the china cabinet. took that speaker out of his car and put it in the cabin and played swept frequencies until we got it to resonate just the same. They have identified, they could get it to replicate with that speaker in the cabin. So it was pretty neat. They used one of the guy's car stereo systems to at least pinpoint where the issue is. So Flight 5 is going to focus a little bit more. Flight 5 is coming in probably, I don't know, I guess months, I don't know. You fly when you're ready, so it could be weeks, months, who knows. But that's what we've got is that. Okay.
I want to apologize for interrupting, but we just have to have another appointment we've got to make.
Oh, okay. No problem.
Sure appreciate your.
Thank you for coming. Let's see, what's my time? Oh, yeah, I'm overtime, sorry. Let's see here. We're almost done. So here's the gear down and fixed, no gear doors. Open gear door bays, as you can imagine, very rumbly. You could park a car in that gear door. It's so big. Yeah. And then here's Flight 4, the recent flight. This is clean. This is what we call clean. And we, as engineers, have been waiting for this photograph. It is absolutely beautiful. Okay, so here I want to show you the video. See, is it moving? Yeah. Okay, gear doors open. Retract is commanded. There is an orchestra of hydraulic signals happening to make this work. And it's incredibly orchestrated. So gear goes up, 34 doors close. Yep. So each of those gear bays is all coordinated in and of itself, so they all think they're alone. They operate on their own. They're isolated in ways hydraulically and electrically that they don't know each other's there, so they all do their own thing. To see them go up together is just kind of cool, but it wasn't intended necessarily. Gears can go up at different rates. Want to see that again?
Yeah.
I like watching it. So first the nose gear doors open, and they go up. Those tires are 34-inch diameter tires, so they're huge. Each one of them are 34s, and
That's beautiful.
yeah, it's just beautiful. So yeah, go ahead.
Do you have a landing gear light for each set of gears in the cockpit?
No, you have one
Oh, no.
green and one red. The flight engineer has a computer that has vision on everything.
Okay.
So the flight engineer will monitor individual gear, and they'll get a code. So we have a caution and advisory system in the airplane, and the pilots will actually see if there is any problem with any one of the gears, and we have a code, and it's a weird code, but it's LMMG is left middle main gear.
Oh,
So we have to, so the code will be LMMG up.
I don't have a diagram.
And yeah, so there is a bit of a decoder ring, and you know, when you think about it every single day, you kind of learn the code. Okay, I think I'm down to the very end here, and I want to point out, like, there's a human side to all of this, of course, and it's very important. This is how it feels. Like it is the day of flight. We've only flown 4 times, and each and every time it feels special. It is.
Like the first flight.
It is. You show up at 3 o'clock in the morning, and I don't know where I find the energy, but I end up going out and partying with the guys until 10 o'clock that night. It just, the spirit that's there is motivating. This is why we do it. Here's the entire team that flew on Flight 1. This is first flight, right after we landed. And here's the air crew coming out after they towed back. The air crew stays in the airplane during tow back, just to keep an eye on brakes, hydraulics, and things like that. And then here's the celebration of first flight. Tradition to first time a pilot's flown in an airplane or flies the airplane, they get soaked. And in this case, this is a water that they're getting shot with. And they know they're getting it, so they usually run around and try to run from it. But it feels amazing to stand there and watch something you've worked on for so long fly. But on top of that, to break a record. So when I saw this airplane take off for the first time, what went through my mind was, Howard Hughes, we're higher than the H-4 Hercules. We've now flown farther, and we've now flown longer time. And then when we flew on the second time, we flew twice. And that no one's keeping score, but we're keeping score. And it's kind of feels, to me, it feels very good to have that happen and to have it, to this day, it's super exciting. I've taken my kids out of school to come watch because I feel like it's a milestone of importance, and someday they'll be like us and they'll say, I saw that fly for the first time. So keep an eye on our social media. Let me show you. So what's next? We're going to add the pylon. The next time you see this fly, you'll see a launch pylon underneath the center part of the wing, but you won't see Talon yet. We're going to step into it easily. First we fly with the pylon, then we fly with the payload, and that's all to keep our pilots and our friends safe. But we're doing something new that I am really excited about as a company. Is we're going to broadcast on YouTube. So we broadcasted Rock Flight 3, and we do so with NASA. And the reason why, it's because NASA. They have the most amazing media team in the world. And why would we try to build a media team? Our company is an airplane company. We hire the experts with the media. They use the long-range telescope from Edwards, and they use their team to put cameras all over our field, and they're broadcasting chops, and they do a wonderful job.
Would you explain which NASA that is?
It is, this is...
It's a commercial company.
It is? Okay, NASA Space Flight.
It is
Yes.
not NASA, it's not the National Aeronautics and Space
Okay,
Administration.
it's
It's
NASA
a private
Space Flight.
company that liked the name.
Okay. Oh, okay. All right. And well, I don't know how they connect back with the long-range optics, but somehow they do. And we get the benefit of watching our airplane fly clear past Red Rocks State Park and still be able to read the tail numbers from Edwards. And it's this optics that I believe was originated for the shuttle program, right?
Right.
Yeah.
Same optics supported Spaceship 1 and Spaceship 2.
Spaceship 2, that's right. And it tracks.
There's just range services from Edwards.
Okay. And that's the only genuine NASA effort, I think, in this probably. Because the guys that run this they're YouTube personalities. And I got the fortune of being the narrator on Flight 4, so if you go watch Flight 4, you'll hear me. And there's 35 people behind the scenes working on making that presentation work out. Well, good news is Flight 5 will be broadcast just the same, and you'll see even more coming out. So we're being as open. We're kind of trying to be a little bit like SpaceX with how open they are with their progress and their endeavors. We get a lot of benefit from that. So yes, sir. In the back
Are we going to get any advance warning on Flight 5? I've never seen a launch or landing.
Yeah, a little bit. Yes.
How much you think?
Probably about a week. So as we get more down the road in flight, we give a little bit more warning. We didn't in the beginning because we didn't want a crowd in the beginning, and we actually kept it very quiet. One of the biggest threats to us here are publicly flown drones. And that is an issue. And Mojave Airport, like most, are actually under the veil of no-fly, so some of the out-of-the-box drones don't work. But there are people who are smart and can make them work anyway. So what we have are roving patrols looking for drones because that's the biggest threat to our airplane, actually. And so if you see anybody flying a drone, question them that they don't belong in the airport. So if it's over the airport, that's where it's supposed to be.
So the advance warning will be on Facebook?
Yes. Yes. And Twitter. Mm-hmm.
Excellent.
And that's one of the ways that you can keep an eye on us. Yeah.
These are on YouTube. Can you get these now?
Yes, you can. So these are the links. Sorry, they're hard to remember. If you just search Rock Third Flight or Stratolaunch, if you search that in YouTube, it'll go right to them. And I put these on here because this is the page you're looking for. And these are the ones that have all the real information in it. And they're long. This is 5 hours and 45 minutes long, and this one's a little over 2.5 hours. Yep. So, yes, sir.
Why no drones?
They're dangerous. We don't want them to run into the big airplane. Yeah, and you can't see them when you fly. They're so small. They're about the size of a bird. So anyway, check out our website, and this is stratolaunch.com, and come help us if you need a job. Want to help out? We got plenty of career opportunities. I put this photo. I'm a photo shutterbug lover of good photography. I don't know who took this picture. If it was you, thank you. Yeah, this just shows the feeling of what it's like. This is actually by Business 58. The airplane will ever only land on on runway 12.
Is that what
That's,
they're doing up in their own car? I
Yeah.
love that.
Yeah.
I love that. I
So-
found that online and
Yeah.
I used that.
yeah. So
Diane said that you could actually, after the airplane goes over, you can actually hear the
The
wingtip
vortices.
vortices.
wow.
Yeah.
Yeah.
So
So
I've got to go
questions?
experience
Yeah.
it
Did Paul Allen finance most of this? Or
Yes.
did he-
in the beginning.
Yeah. Paul
Anybody
Allen-
say thank you to him?
Yes. Paul Allen financed this all the way up till first flight. And he died shortly before first flight, unfortunately, just a couple months beforehand. 4 months, I think, 3 to 4 months beforehand.
And then another company has.
Yep, and then since the company sold to, the company that has it now is Stratolaunch, they just took the same name. But Paul Allen's group is no longer part of it. It's a completely self-funded, standalone company now. Yes, sir, in the front.
Is there a plan for number 2?
There are no plans for number 2.
All right.
Nor is there any partially built number 2s. Yes, sir.
Is the runway width an issue? I mean, would you rather have a wider runway?
Yeah.
Yes, definitely.
Because
So,
it's 200 feet
Mhm.
wide and your wing, and your gear is what, 185 you said, or?
no, it's approximately 105, about
Only
about at
105.
100.
Okay, that's
Mhm.
not bad.
It's not as bad, but it really does limit you to about 50 feet on either side. And it's also the configuration of the landing gear make it such that the nose wheel steering is not very effective.
Oh.
And so it tends to taxi much like a tail dragger. And you end up using your differential brakes a lot.
To
Busy
stay
feet.
straight.
Very busy feet. Our rudder effectiveness drops off considerably on the ground as well. And so runways are all painted in a very consistent format across the country, and we asked if we could put a stripe on the center line of the right fuselage down this runway, and the answer was a hard no. The FAA would not allow a stripe, an extra stripe on this runway, because it's out of consistency with runway markings. And it's a very good point they make. So what we did was there is a repair down the runway, and you know how they put tar on a crack, right? Oh, it just happens to be a crack all the way down the runway at 90 feet that's repaired with black paint.
Yeah.
It's a repair, but the pilots see that and they use that actually as their lineup line. So, well, that's all I've got. Any further questions?
Thank you.
Oh, in the back. In the back.
Oh,
Yeah.
No, 3 quick ones.
Sure.
Talon land powered or like the shuttle?
I'm sorry, Talon.
Does it Talon land like the shuttle or is
Oh.
it under power?
It lands like the shuttle as a glide only, so it just powers through the Mach 5 run and then slows down and does a final glide.
When this aircraft went under contract, you said it still had the escape pod under the SRB.
No, actually that had gone and it turned into a flyback pod. So it actually had a ballistic parachute idea where it would detach and come back down under a ballistic parachute in concept. But that was quickly scrubbed for obvious reasons of reliability. Yeah.
Last question. I thought I heard you say the left fuselage cabin was just for looks. There's no windows in it?
There is windows in it. Yeah. Yeah. Yeah, I apologize. Yeah, it's built.
White Knight too.
Yeah. White Knight 2 is just decals on the left.
Thank you.
And they look, yeah, they're dark. And it's actually not pressurized in White Knight 2. But because ours is pressurized, we opted to have windows in both because we only tested one configuration. So, yeah. Yeah. Any other questions? Oh, yes, sir.
Hey, if I may interject, top end of Mojave Air and Spaceport, the marking situation, he's exactly right. We had to apply the FAA to, we had to apply for non-standard markings. We had to go through this whole process of
Very nice that we can slow down like that. Yeah, our max cruise is only ever going to be 185.
What's the wing loading on that, pounds per square foot?
That's a good question. I actually don't know that off the top of my head. I don't know. I'll have to look into that.
After you get the max gross weight, then you can figure it out?
I don't know what the area, the wing area is,
Yeah.
though, off the top of my head. I used to know. Oh, the only reason I did know is that I like to compare it to like real metrics, and the wing area was close to that of a football field area. So I used to call this chart "building a flying football field," but or this presentation, but I'm not that big of a football fan. I love it, but I'm more of an airplane
It's
fan.
hard to comprehend.
It is. Yeah. So thank you for your time. Yes.
You show 6 engines on this aircraft, and you said when you take off, you're not at full throttle or anything.
Correct.
Is there a reason why you needed 6?
Yeah, so there is, and there's a reason why we don't use the full power still. So on the side of why did we choose 6 engines, that was ultimately for the 550,000 pound payload, and we needed that kind of power for that. And in that case, when we're max gross, we probably will use close to max power for that. Now, the reason why we don't go ahead and just push it up now, we have a little bit of a design issue. The inboard most engines are kind of close to the flat-sided fuselages, and they have a tendency to want to stall. So you can get, we've actually in test accidentally got a compressor stall in the ground by running them up too high, sitting on the ground. And what it is the engine can't suck the air in past that fuselage. So the ones that are there, the one that's closest to the fuselage is fighting its neighbor for air and the fuselage for air, and it'll stall out. So there's a routine where when they take off, they advance the inboards slowly, and the outboards come up slowly behind them, because the inboards, you got to be careful to keep them from stalling, and the outboards, you got to be careful from sucking up debris from they overhang the dirt on the runway. So they are the last to start and the first to get shut down, the outboard ones. And it's for the reasons of that. And here at this airport, we got these little birds. These little, I don't know what they are. I think they're grackles maybe?
Yeah.
But they're everywhere, and they are here first. And they are so obstinate about moving. The airport really works hard to get rid of them for us, and we have a little count on the side. Every time we go out and taxi, every time we go out and fly, this airplane has bird strikes.
Oh, gosh.
So it is that big.
So you're fighting your...
Constantly.
I want to present to you a Plane Crazy Saturday hat.
Oh, thank you.
Because I know you are plane crazy. But wait, there's more.
Oh, thank you.
There you go.
A Voyager 35th anniversary T-shirt, and I think that's our friend Jeff Cloud in Florida designed this, and I think it's a great picture of the Voyager. And we have these shirts for $20 a piece if anybody wants one, but you get one for nothing.
Well, thank you.
All this wonderful information. Thank you so much.
All right. Thank you for the opportunity. I appreciate it.
Take a picture of Mason and I and send it to
And the
Cam
shirt.
will.
And the
And the
shirt.
shirt.
Okay.
Yes.
Guess our photographer left.
Yes.
One with a